of you listen. We have seen so many system of forces. Optional collinear forces, concurrent forces, concurrent parallel forces. All forces having same plane only. Here, each force having different planes. Okay, it is a force all on coplanar forces, called as spatial forces. To analyze the spatial force acting over any member, we need to know three-dimensional Cartesian coordinate system. Okay, two-dimensional coordinate system is the XY. It is a two-dimensional coordinate system. Here, every point having two coordinates, x, y. Understand? Force passing through here, all coplanar forces passing through the two-dimensional points only, 2D points. Here, every spatial force passing through three-dimensional point, 3D point, is a 2D point. 3D point having three coordinates. Number one, x coordinate, y coordinate, z coordinate. X coordinate indicates the distance of this point along with x-axis. Y coordinate, distance of this point along with the axis. And z coordinate indicates distance of this point from along with z-axis or distance, perpendicular distance of this point from yz plane. X point indicates distance, perpendicular distance of this point A. X, the x value is the perpendicular distance indicates, x value indicates the perpendicular distance of this point A, perpendicular of point A from yz plane. Okay, it is the z, x, y is the z. Yz plane is, this is the yz plane. Two coordinates forms one plane is like this. This is the distance, this is the front plane. And y indicates perpendicular distance of the point A from xz plane. All of you know this. Z coordinate indicates perpendicular distance of this point A from xy plane. Okay, perpendicular distance of this point from xy. This is xy plane. This point, this distance. From board, y indicates distance of this point from the board. Board is the xy plane. Board indicates xy plane. Okay. Once you know this much of idea, it's very easy. We are going to cover only spatial concurrent forces which are passing through the origin only. 0, 0, 0, 0, 0, 0. Next, I am considering single force. Then go for multiple forces. Single force. is through point A and point B. Point B. You forces one special force. Analysis. We are going to analyze. Analysis. We are going to analyze the special force first. Then go for multiple forces. First analysis. First analysis we are going to one special force. Having three components. Every inclined force in coplanar system or two-dimensional system having two components. Here three components. Px is the Py is the Pz. The effect of this part P along with x-axis. Effect of this force horizontal effect. It is a vertical effect. It is perpendicular to these two. All three Px, Py, Pz all are perpendicular to one another. All are perpendicular to one another. All are perpendicular to one another. They are effect of this in three directions. In spatial case, spatial force, it's having effect in three directions, three mutually perpendicular directions. Every inclined coplanar force having in two directions, two mutually perpendicular directions. Here, every spatial force having effect through three mutually perpendicular directions. All are with a single point. All three Px, Py, Pz effects. It has along Px. This is Py. This is Pz. All are with and P also. All are the component forces. All component and the resultant. Px is nothing. P is nothing but resultant. P is equal to root of Px square plus Py square plus Pz square. All are with a single point. Px is equal to P cos theta x, P cos theta y, P cos theta z. Theta z, it is the theta x. Theta x is nothing but inclination of this force with respect to x-axis. With respect to x-axis. With respect to y-axis, theta y. With respect to z-axis, theta z. The theta z. Just like Px, how to calculate? P already know, we will give you, but we should know cos theta x. How to get it? Theta x. I am considering in order to determine 2 points. In order to determine theta x, I am considering 2 points. It is passing through two spatial points. A is xi, yi, z. B xj, yj, zj. Correct? It is the line. L is cos theta is equal to cos theta x. How to get it? Adjacent side by hypotenuse. Correct or not? Adjacent side is this is xz. It is xj, yj, zj. It is xi, yi, zi. Distance up to here xi, up to here xj minus xi by l. Okay, how did you tell? L is equal to root of xj minus xi whole square plus yj minus yi whole square plus zj minus zi whole square. Okay, that's all. Cos theta y is equal to yj minus yi by l. Cos theta z is equal to xj ZJ minus ZY. That's all. First single one. First single one. First single one. Once we are having more than one. P1, P2, P3 is there. Suppose P1, P2, P3, P4. All are four forces. For P1, tell me. For P1 case. For P1, how many cases? P1 cos theta 1x. That's all. For P1, P1. X component P1x is the x component of P1. Correct? P1 cos theta 1x. P1y. P1 cos theta 1y. P1z. P1 cos theta 1z. Similarly, for P2, components of P1. Next, components of P2. I am talking about P2. P2x, P2y, P3z, P2z. It is P2 cos theta 2x, P2 cos theta 2y, P2 cos theta 2z. Correct? Next, we come to the theta 3. P3x. P3x. Component. X component of the P3. P3 cos theta 3x. P3y. P3 cos theta 3y. P3z. P3 cos theta 3z. Next, P4. Components of P4. P4x, P4y, P4z, P4 cos theta 4x, P4 cos theta 4y, P4 cos theta 4z. Okay. Resultant. How can you determine the resultant from here? Already know. How to get resultant? Sigma x is equal to, that is equal to Rx. Resultant also comes three components. Get Rx, Ry, Rz. Pattern sigma y, sigma z. Understand my point here? P1x plus P2x plus P3x plus P4x. Okay. Here P1y plus P2y plus P3y plus P4y. This is P1z plus P2z plus P3z plus P4z. Resultant R is equal to, all of you see here, resultant R root of Rx square plus Ry square plus Rz square is the resultant value. Magnitude over. Magnitude of the resultant for the spatial force R is equal to root of sigma x square plus sigma y square plus sigma z square. That is equal to root of Rx square plus Ry square plus Rz square. Next, direction you should know. How to determine the direction? That is alpha x. That is the direction. Direction of this sigma x with respect to the x-axis. That means cos inverse Rx by R. they are passing through another point, one point A, P1 passing A, that is A, 3 to 5, and this one A, B, P2, P3, this is P3, this is P4, this is point B, it is passing through C, it is point through D, it is passing through D. We should determine here, we should determine the resultant of the system of forces given in the system. How to determine? Tell me first. Every time we are determining four characteristics. Number 1, magnitude. Number 2, direction. Number 3, push or pull. Number 4, point of operation. Point of action. Point of action is once all are concurrent forces, our resultant also concurrent to that same point. It will meet at the same point. That's why this is our point of operation. Over. All are acting pulse. All are pulse here at upward direction. That's why this one also, our resultant also may be like this. Some pull. 2 over. We should determine inclination or direction of this car with respect to x-axis, y-axis, alpha x, alpha y, and alpha z. We should determine inclination of this car with respect to x-axis, with respect to y-axis, and with respect to x-axis, and magnitude r is equal to root of rx square plus ry square plus rz square. For every spatial force having 3 components, one is along x, along x-axis, one is along x along y-axis, another is x along z-axis. Okay, Rx is nothing. Please see all of it. Already we explained now. Rx is equal to sigma x is equal to P1x plus P2x plus P3x plus P4x. Ry is equal to sigma y is equal to P1y plus P2y plus P3y plus P4y. Next, Rz is equal to sigma z is equal to P1z plus P2z plus P3z plus P4z. We have to calculate all values according to the given data. Forces given the forces. This is 10. P1 is 10 kilonewton. P2 is 20 kilonewton. 20. Correct? 20 kilonewton. P3 is 25 kilonewton. P4 40 kilonewton. That's why P1 50 kilonewton, P2 25 kilonewton, P1 10 kilonewton, P2 20 kilonewton, P3 25 kilonewton, P4 40. This force passing through point A, that is 3 to 5. This force passing through point B, 4 minus 3. Correct? Minus 3 is correct. This is minus 3 or not? Yeah. Fantastic. From here, you can easily determine. First of all, we should determine L1. L1 is 0.8. This is the distance. It is 0, 0, no? L1 is root of L1 root of 3 square, 3 minus 0 whole square plus 2 minus 0 whole square plus 5 minus 0 whole square. Next, L2 1 minus 0 whole square plus 7 minus 0 whole square plus 4 minus 0 whole square. Next, L3 root of 4 minus 0 whole square plus minus 2 minus 0 whole square plus 4 minus 0 whole square. L4 minus 2 minus 0 whole square plus 4 minus 0 whole square plus minus 3 minus 0 whole square. The value after determining L1, L1, L2, L3, L4. L4 values. L1 238, 36, 66. That is L3 is 6, L4 is 29. Okay, but we should know P1 x. There is also having three coordinates. Number 1 is x coordinate, y coordinate, and z coordinate. P1x. P1x is equal to P1 cos theta 1x. P1 y equal to P1 cos theta 1 by P1 z. P1 cos theta 1 z. That is equal to P1 is how much? P1 is 10. 10 into cos theta 1 hypotenuse, that is this length. This length 3 pi. This is the value by root 38. This is 10 into 2 by root 38. This is 5 by root 38. P1x. P1x value okay. Next, P2x is equal to P2 cos theta 2x. P2y, P2z, P2 cos theta 2y, P2 cos theta 2z. It is 20 into 1 by root 66. It is 20 into 7 by root 66. It is 4 by root 66. Answer is next. Components of all components of P3 is P3x, P3y, P3z, Z. That's P3, P3, P3. Cos theta 3x, cos theta 3y, cos theta 3z. P3 is how much? 25. 25 into 4 by 6. L is 6. 25. 25 minus 2 by 6. Next 4 by 6. Next all three components of P4. P4x, P4y, P4z, P4, P4, P4 cos theta 4x, cos theta 4y, cos theta 4z. This 40 distance, this distance is minus 2 by length is root 29. Root 29. 40 4 by root 29. 40 minus 3 by root 29. Finally RX is equal to P1x plus P1y plus P2x, P3x, P4x, RY, P1y, P2y, P3y, P4y, RZ, P1z, P2z, P3z plus P4z. It is the inclination of the resultant. It is the I am just drawing the resultant only here. Is the resultant force or the x, the y? This is the z. This is x along with x or x. This is x along with or y. Or z. It is inclination of resultant with respect to x axis or y axis. It is the inclination of the resultant with respect to y axis alpha y. This is the resultant of this one to the z axis alpha z. That's why alpha x is equal to cos inverse rx by r. Alpha y is equal to cos inverse ry by r. Alpha z is equal to cos inverse rz by r. We should know rx, ry, rz values. This is all. Stop. Get. Please see. P1x value is one. P1y 3 points. All we calculated. After that, Rx is equal to sigma Px. That is the P1x plus P2x plus P3x plus P4 values. All we are getting from here. Finally, we got 9.14 kilonewton. It is 41.856 kilonewton. Finally, this is 12.743 kilonewton. Our resultant R is equal to root of Rx square plus Ry square plus 1 minute. Next, finally, inclination of this resultant. Actually, we calculated. Next, determine the direction. Direction of resultant with respect to x-axis is cos inverse Rx by r. That is equal to 78.17 degrees. in the rightward direction.